The directed network below shows the sequence of activities, A to S, that is required to complete a manufacturing process. The time taken to complete each activity in hours is also shown. The number of activities that have a float time of 10 hours is 0, 1, 2, 3, or 4 activities. Okay. So this is a question that requires a forward scan and to determine the earliest start times, of course. Then a backward scan to determine the latest start times of all the activities, and use that to then determine the critical path. And obviously all activities on the critical path will have a 0 float time. So obviously they're not going to be counted and we're not going to even consider those. The non-critical activities, that's when we need to then work out the float times and then obviously determine which of the activities have a float time of 10 hours. Okay, so let's do the forward scan first. So starting off with 0, 0 plus 5 is 5 hours, 5 plus 4 is 9 hours, okay, 9 plus 3 is 12 hours, okay, we have 12 plus 7 is 19 hours. So we'll stop there because we need to consider some other parts. 5 plus 7 is 12 hours, 5 plus 1 is 6 hours, okay. Now, to get to this vertex here, we've got an option of 6 plus 8, which is 14, or 12 plus 6, which is 18, and 18 being the higher of the two, so I'm just going to put 18 there. Okay. Now, to get to this vertex here, we've got two options. 12 plus 4 is 16, or 16 plus 3 is 9. 12 plus 4 is 16 is the higher of the two. So with forward scanning, it's always, it's always the higher of the times. If there's more than one way to get to a vertex. Okay, so at this point, we're going to consider this vertex here. Okay, so 18 plus 6 is 24. We've got 16 plus 5 is 21, so 24 being the higher of the two, so we'll put 24 there. Okay, so 19 plus 2, now to get to this vertex, 19 plus 2 is 21. Okay, we've got 18 plus 5 is 23. We have 24 plus 1 is 31. So 31 is the higher of the two. Okay, so at this point, we've got numbers, or at least the earliest start times of all the vertices up to this point. So we've got 2 more to go till we get to the end. And then we have the finished vertex there. So 31 plus 8 is 39. So 39 plus 1 is 40, or 31 plus 11 is 42. So 42 being the larger number, we'll write 42. And then 42 plus 9 is 51. So this project takes 51 hours to complete. Now let's do the backward scanning. So we're going to start from 51, and obviously we're going to end up at 0. So working backwards. 51 minus 9 is 42. Okay, 42 minus 1 is 41. Okay. Now, we have 42 minus 11 is going to be 31, and that's going to be the lower number compared to 41 minus 8, okay, which is 33. So 31 will go here. So now working backwards again. So 31 minus 2 is 29. It's basically the same process. Going backwards, if you recall, backward scanning, it's almost practically identical to forward scanning, except just everything in reverse. So if there's 2 ways to get to a vertex going backwards, we take the lower of the 2 numbers instead of the higher. So 31 minus 7 is 24, because there's only one way to get to that vertex. Okay, 24 minus 5 is 19. Minus 4 is 15. I'll stop there because there's now 3 ways to get to this vertex, so I'm not going to go any further. Now you've got 31 minus 5 is 26, but we also have 24 minus 6 is 18, so 18 will go there. So 29 minus 7 is 22, but we have 18 minus 6 is 12. Twelve minus 3 is 9. So 9 minus 4 is 5. Now we can't get any lower than 5, so we can be confident that that'll be a 5 there. Okay, now we have 19 minus 3 is 16. 18 minus 8 is 10, so we're going to put the lower of the two numbers there. And I think now we have two numbers now on all the vertices. So now let's determine the critical path. Okay, so we know, I'm just going to use a highlighter, so I'll just test the highlighter, make sure it works. Yes, it does. Okay, so we've got there and there, so we know clearly that has to be a critical path because it's the only way to get from start to finish is via those two edges there. Okay, so we have that vertex there, okay, is on the critical path. 18, 18 is on the critical path. Okay, 9, 9, 12, 12. 31, 31. Okay, so this is on the critical path there. Okay, that's on the critical path. Okay, this will be on the critical path, E. Okay, this will be on the critical path. Okay, this will be on the critical path. And this one here will be on the critical path. So there's our critical path. So now let's consider the activities that are non-critical and work out their float times. So activity C, I'm just going to do them in no real order, but just as they come. Okay, so the way we work out the float time is we take the LST next, so 15. Okay, 15 minus 7 is 8, and 8 minus 5, so the EST is 3. So C doesn't have 10 hours float time. Okay, let's have a look at H. Okay, so we take the LST next, so 19 minus 4. Okay, that's 15. 15 minus 12 is 3. Okay, so it's neither that one nor that one. Okay, we've got activity L. So again, you can take the second number, so LST next, 24 minus 5 minus 16. So that's 3 again. So 24 minus 5 is 19. 19 minus 16 is 3. So it's not that one there. Okay, we can see that it can't be R because we've got 42 minus 1 minus 39. So I'm not even going to bother working out R. I know it's not 10, so I'm not going to waste my time with that one. Okay, what about N? Now, 31 minus 2 is 29. 29 minus 19 is 10. So N is, or has a float time of 10 hours. Okay, so that one clearly does. Let's have a look at I. Okay, so 29. Okay, so LST next, 29 minus 7 is 22. 22 minus 12 is 10. So I also has a float time of 10 hours. Okay, let's have a look at activity G. So 19, so again, LST next, 19 minus 3 is 16. 16 minus 6 is 10. So G also has a float time of 10 hours. Okay, now we have M. Okay, so 31 minus 5 minus 18. So 31 minus 5 is 26, 26 minus 18, well, that's not going to be 10 hours. Okay, so M's not that, doesn't have a float time of 10. And we have F is our last one. So 18 minus 8, well, that's 10. And 10 minus 6, well, that's not 10, that's going to be 4 hours, so F's not there. So it's in fact these three activities there that in fact have a float time of 10 hours. So the answer is D, 3.